I'll be walking around, no? So tanggalin ko tong mic, no? Let's see how this thing goes. I was advised not to go too fast because the camera might not be able to follow me. No? Pero I'll walk around, no? Hopefully that's fine. So good morning. Welcome to day 2 of RootCon, no? Medyo inaantok pa tayong lahat. I as well am very sleepy, but I had good sleep. Not sure with everyone else. No? So good morning. Welcome to my presentation. I'll be talking about how attackers are compromising your networks, no, not ours, compromising your networks and what you can do about it. The main reason why I wanted to present this was I had a very sad feeling that most of the organizations, especially in the Philippines, are not aware of how attackers are compromising them. What do I mean by that? Well, we always see organizations get breached. But the amount of tools and the amount of solutions that we have, I don't think we have a shortage. But I think one of the main reasons is the lack of understanding of how the attacks work. Right? For example, well, I don't want to get compromised. I better buy an EDR. Well, to be fair, that's a requirement today. But the attacks that the EDR detects, do you understand how they work? Or do you understand how your dashboard works? Or do you understand how the alerting appears, but not really what happens under the hood? Now, I won't be able to cover everything because there's too much going on. InfoSec has been out there for a long time, and the increase of attacks are quite exponential. But I'll do what I can to give you a at least a starting point to understand some of how these network attacks work. As a side note as well, I remember one of my capstone for LaSalle was to create a guide of how organizations could secure AD. Because most of the organizations we tested, when it comes to their Active Directory, within a day, or even within hours, we are basically domain admin. The sysad is clueless. He doesn't understand what happened. He tells, it's the vendor who configured. I don't know with the vendor what are they doing. So that just saddens me about that fact. No? So a little bit about me. Let me remove this. Right, anyway. So a little bit about me. I'm CJ. Currently I'm an OffSec manager at Redrock. So we are a local IT services provider in the Philippines. If you need a pen test, MDR, IR, security assessment, you know where to look for. Currently, I also started teaching for the SANS Institute. So I teach the 560 course, which is the enterprise pen testing course. Very recent. So if you've taken GPen, that's the course I started teaching. I'm also doing a bit of continuous study with information security, and previously I did it with LaSalle as well. So I have a few certs. I initially started as a blue teamer in a government agency in the Philippines, very famous. No, you don't have to search. No, it's very easy to figure out. Then I went to the private sector, and then I worked pen testing from there. So I did a bit of IR in the government sector, which you could imagine how could be that difficult. No. So my outline, I will give you some of the attacker phases, the most common ones, and then I'll give you an overview of how attacks in Windows work. Now, if you are trying to figure out how NTLM works, what is an NT hash, what is a Kerberos ticket, what is a golden ticket that you always see in your platforms, I think you went to the right talk. Now, of course, I can't give you an overview, complete detail of everything. It's too complex. But hopefully, if you go out of this room, after this talk is finished, you have an idea what's the difference between a golden ticket and a silver ticket and other types of attacks. Then lastly, of course, as all red teamers or blue teamers, I'll give you some tips or general guidance of how you could secure or remove those issues. Just a starting point in those cases. Of course, there is no attacker presentation without the MITRE. I went ahead with the cyber kill chain. So cyber kill chain, if you're familiar, 7 phases. Every time I say cyber kill chain, Lockheed Martin gains 2 cents. Cyber kill chain, recon, weaponization, until actions and objectives. The case with cyber kill chain, while it was representative of how the attacks were, it kind of became underwhelming that it did not cover internal threats, for example. It did not cover different scenarios, but during that time, it was much more relevant. Now, another framework that attackers or us defenders could refer to is the amazingly large MITRE ATT&CK framework, which doesn't fit in one slide, right? As I've said from my talk yesterday at Red Teaming Village, it doesn't fit at one slide anymore because there are so much attacks that are, or rather techniques, that could be used by attackers just to achieve their tactics or their objectives. If you want to look up MITRE ATT&CK framework, it's online. If you're not aware of it, it's now time to be aware of it, no? Because it's basically the lexicon of the industry right now. So if you ask me, there are just 3 simple attacker phases. Cyber kill chain, very nice, very nice. Attack framework, good guide. Unified kill chain, good guide, whatever. But for me, there's just 3 things that are really going on. One, attackers need initial access, right? They would need access inside your network. Then once they're inside your network, unless they compromise the domain admin already, which seldom happens, never have happened in my life. Hopefully it happens before I die. They would then escalate privileges after gaining initial access. Now, after gaining that privilege inside the network, they will now work on their objectives, right? For example, if you've listened to some of the presentations yesterday, especially the one from Aaron, most of the threat actors, once they get in, they want to do something, or they actually have an objective before getting in. Do they want to encrypt your data? Do they want to steal your data? That's basically phase 3, their actions and objectives. Now, let's try to look into how attackers would gain access first. Several techniques. Some of it would be applicable for pen testers. For example, phishing would be one. Let me just... phishing is one, right? Phishing is one example that attacker could use to get in, or even a pen tester. Logging in from a publicly exposed service, very common. SSH. You might not believe that it's 2024. There are still RDP services that are exposed in the internet. I don't know why, but still there. You could also look into publicly exploitable or services that are vulnerable with public exploits. The most common CVEs, right? 2024. I forgot. There will always be a public exploit that will be working on exposed services. Now, internal rogue devices and supply chain attacks, these are like meh for a pen tester. It's basically out of scope, right? If you go into supply chain attacks, you're basically going out of scope. You try to compromise. Like for example, you want to get in via supply chain attack, you have to compromise that other third party who's not within your contract. So it's basically non-negotiable. Internal rogue devices, well, how do you get in at offices today? Different scenario. So if you ask me, how do orgs get compromised initially? It's usually these steps. Of course, there are other scenarios, but the best of my knowledge, these are the most common ones. Now, when they get in, they would now explore your AD environment. Now, let me see a raise of hands who have of those people who have a good understanding of how Active Directory works. I would assume those who raise their hands are uncertain, they do, and those who really did not raise their hands, they know it, because they're pretty shy to raise their hands. No one knows? You all know it? Okay, everyone knows. I see some benefits. Okay, so let's skip this slide. No? So let's skip this slide. So it's basically AD is just a database of how details inside your domain currently are. Some of the services that AD supports, there are links of where to look into tons of resources. You could die reading before you complete all of them. There's so much Active Directory best practices. If you even look into Microsoft documentation, they have a huge resource of this one. I don't think, in most cases, I don't think there is a lack of available material. It's more of I think the reason why a lot of organizations are insecure, it's because of they don't really get to apply it, or there are just other priorities of other orgs. But when it comes to resources and the available tech and features for it to work, I think it's there. We are just not aware of it. So it's motivated from a previous talk of Sean Metcalf. If you've been to adsecurity.org, he is the maintainer of that website. Fantastic guy. If you want to learn about AD, he is the #1 resource. Very smart. He's like one of the few hundred people who are Microsoft MVP when it comes to directory services. So let's look into some of the attacks related to Active Directory in the past Not 10 years, obviously, because that slide is wrong. So 1997, originally pass the hash was discovered or was published. Now by 2001, from CDC, they released SMB Relay and SMB Relay 2. Right? So if you've heard of SMB relaying or basically NTLM v2 or NTLM relaying, it's been there for 2001. 2007, abuse or tools to abuse LLMNR or NDNS. For those who aren't aware, linked local multicast name resolutions. Basically, if your DNS fails, this is what your Windows host will do. Right? 2007, that tool was released. Then by 2008, anyone here inabot yung Windows Credential Editor, no, yung version na before nun, yung Pass the Hash Toolkit. I'm pretty sure a lot of people did. Me, I did not. No, I was still in, I think, elementary high school that time. And then, by 2010, Windows Credential Editor was released. That's 14 years ago. Now, fast forward to a few more years. By 2011, oops, there it goes. Right, I forgot. Wait, that's too early for me, no? For those who don't know. Yeah, but well, after I had my hot choco coffee and now we have, I don't even know what that is. No? So, yeah. So, by the way, this is my first time speaking at RootCon, so that's how it feels pala. No, so, going back, 2011, the first version of Mimikatz was released by Benjamin Delpy. If you don't know Benjamin Delpy and you are a pen tester red teamer, you are not a pen tester red teamer. Benjamin Delpy authored Mimikatz. Now, Benjamin Delpy, just to give you a background, is French. He's an IT manager for a government sector back then. And the reason why he published Mimikatz is he wanted to demonstrate that there is an issue with how Windows authentication works, specifically WDigest. He realized, after a bit of research, that, hey, Windows, or rather, Windows, stores credentials in memory so that it will be seamless for the user when they authenticate to remote services. Right? So you could just log in once, your credentials will be stored in memory, and then you could authenticate remotely. Now, the key to that secret is also stored in memory. So Benjamin Delpy realized that, and he had another motivation. He wanted to learn how to write in C. So he's the person who realized that there's a major security issue in Windows and wants to learn C. So he's pretty weird talaga, no? So he practiced that. He was able to release the tool. He was being chased by Russian people, if you're aware, no? Of the history. And basically, since he was feeling threatened about his life, in one security conference, after he talked about it, he released the code publicly. But before that, there were active exploitations of threat actors already, of a version of that tool, even though he has not released it. Now, by 2012, for those who remember, the GPP attack or group policy preferences happened. This is when Windows suddenly decided to publish the symmetric key of that file. So they stored credentials in an XML, which is basically symmetric encryption, and they forgot that symmetric key is only secure if the if the only key or the encrypting key is not exposed. Then they released it in documentation. So very big issue, but today you don't really would find that. By the way, Responder as well was released. Now, for those who aren't aware of Responder, guy from Trustwave released that tool, if I got my history correct. By 2013, the PowerShell version of Mimikatz was released. This was 11 years ago. Invoke Mimikatz 11 years ago. No? So, by 2014, this is the golden age of Active Directory exploitation. Why? Well, Benjamin Delpy, the very smart guy he is, released the attack on golden tickets over Pass the Hash and PTT, or Pass the Ticket. That was 2014. If I do the math, 10 years from now. September, or rather at that time as well, Silver Tickets, a blog about Silver Tickets was released. By 2014, of that September as well, Tim Medin, which I have met personally, released the attack called Kerberoasting, kicking the guard dog, whatever, I forgot. It was a presentation in DerbyCon, which is a con in the US. I remember he got rejected presenting that attack, and now it's still being used by a lot of red teamers and pen testers today. He released it by September, and then December, PowerView was released. For those who aren't aware, PowerView is a targeted domain object enumeration in AD. By will show there basically the people or behind Spectre Ops. So if you've heard of the ADCS, yung Active Directory Certificate Services, which I'll talk about later. If you heard about Empire, C2 framework, he developed that one as well. If you heard of GhostPack, Veil, yung evasion framework, he developed that as well. Rubius, basically a lot of tools. That was 10 years ago. Now, where are we currently, right? If you look at organizations, no, a lot of them are still vulnerable to all of these attacks. Basically, past the hash, which was 1997, 17 years back, still works. Why? It's basically you cannot fix it. No, it's how Windows works. Now, let's now deep dive into some of the technical details of why these attacks work. Windows authentication protocols, number one. Windows have two authentication protocols, NTLM and Kerberos. That's their main, Kerberos is the main one, and Kerberos only works in a domain environment. It does not work in your local group or local authentication. Now, there's two versions of NTLM, V1 and V2. What we use now is basically V2, but it's still archaic and very old. Now, that's for authentication over the network. In Windows, the way it stores credentials before is it two ways, LANman and MT. Today, disabled na si LANman, obviously. No, very old, but it could be backported. Some orgs would still use that because of backward compatibility. Now, NT hash is what we usually say as a password hash, no, for Windows systems. These passwords, if locally, are stored in the SAM database. If it's in AD, it's stored in the ntds.dit file in domain controllers. So basically, there are two potential locations for these secrets, depending on what type of hashes you are looking for. Now let's give a few seconds of looking into how LANman works. The old one, right? It's very, maybe at the time it works, no, but if you look at it now, it's pretty stupid. No? The password, no, if you, for example, you give a password of 8 characters, it pads it to make it 14. So password mo was password, how many characters is that? 8. It pads it with 6 characters to make it 14 because it needs it for the formula, right? Come on, we need to pad it. Now, if your password is a mix of upper and lower case, it doesn't matter. It will freaking uppercase everything. So uppercase na lahat, no? This is fantastic to do from a security perspective. Then, it will do another fantastic thing. It will split your 14-character password into 2. That's why when you crack LANman hashes via John, you get 2 results. For those who aren't aware, no? You split the characters into 2, divided by 2, so it's now 2 sevens. And now each key would be encrypted with a fixed string via DES. Data encryption standard. Sa mga inabot yon, for sure meron. Pagsasamahin, yung result nun, pagsasamahin. So parang pinag-require mo yung user mag-password ng mahaba, paghihiwalayin mo, i-ooperate mo ng hiwalay, pagkakabitin mo. So in short, ba't mo pa pinagkabit? Diba? Anyway, pretty insecure, that's why we don't use them. Now, the challenge response, which will be another topic later, is for example, when a user would want or a system would authenticate to a remote service, how will it be able to send credentials safely? Kaya pinasok yung challenge response ni Windows. Si LANman would use the LANman hash as the initial starting point. This is what's going to happen. The client would initiate a connection. The server, no, after receiving that initial connection, would send a challenge. And then the client formulates a response from the challenge. What will it do? It will pad the LANman hash to 21 bytes. No, as if padding it to 14 is not enough. From 14, no, may fetishy Windows sa 7. 7, 14, then make it 21. Then they split the LANman hash into 3 7-byte pieces. So from 21, it will now make it 3 sevens. And then i-encrypt na naman the DES key. Encrypt the challenge and then send it over. Well, you could imagine maybe Windows would improve this in the next iteration with the net NTLM or NTLM v1. Nope, they did the same. Rather than using the landman hash, they now shifted to the NT hash, which is a far better hashing algorithm or password storage, I guess, but still the same. So how is the NT hash derived? By the way, if you are puzzled of how simple this is how your Windows networks, Windows operating systems store credentials today. This is not from history books, guys. This is how it works today. So the full password is hash using MD4. Narinig nyo na MD4? MD5, yes. MD4, mas luma pa yun. No? If you have not heard of MD4, that's how Windows would initially basically start. The hash is 128 bits. So let's say your password is 1234, it becomes like this. Now, what Windows does, I'm sorry for bashing on Windows a lot. No? They will get my praises later, but for now, they suck at this. No? They don't do salting. Ibig sabihin, if my password is mycuteDog123 and his password is mycuteDog123, when our NT hash is computed, it's the same. That's why if my password gets hacked and someone from Ukraine gets hacked and we have the same NT hash, we have a both CuteDog. That's the case with NT hash. No, that's why yung mga attacks before, rainbow tables, naandyan sila, it's simply because Windows does not this. By the way, Linux does this. They do salting, Linux, no? But different case, 95% of the orgs majorly have Windows. No? It's not Linux, so it's far more secure, but that's not most of our assets. Now, NTLM authentication was born. Sabi na, landman sucks. Right? Let's now do NTLM authentication. One thing I'd like to highlight here, no, as I've said, it's very similar to landman challenge response. But I'd like to make this a point. Very, very common in our conversations with our clients. Ang NTLM po ay hindi NT hash. Ang NT hash is the hash stored locally. Si NTLM is the remote authentication protocol over the network. Very clear tayo dapat dyan. Kasi people would throwingly say NTLM, no? Just like how people throwingly say cross-site scripting. No? That's not how it works. NTLM is done over the network. NT hash is your password at rest. Ibig sabihin, yung credential mo na at rest is the NT hash. When you do NTLM over the network, you use the NT hash as an input. If that makes sense. Now, here's what we currently have for challenge and response. It's an improved version. Doesn't mean secure. Just an improved, right? Of course, improvements are better. That's why I wear my shirt, no? 1% better every day. So we improve a little, but you know, that's actually a coincidence. I did not plan that. But the client would authenticate. What happens now here, they would do authentication. Then the server would send a challenge. Aha, of course, challenging every authentication attempt. But here's the fun part. No? They will use HMAC MD5 of the username and domain name. And this HMAC MD5 is a keyed hashing algorithm. So it needs a key. It will use the NT hash as the key. The result would be called as the one-way function, or yung OWF na nababasa nyo. Now, that one-way function would be used as the key for the next iteration. What will they encrypt? It's the timestamp, the server challenge, timestamp, client challenge, and other items. So basically, they're reusing the same key, or the output of the, rather, they're reusing the output of the first process as an input to the second process. Visually, this is what's going to happen. A client would negotiate, I want to connect via NetNTL or NetNTL v2. Here's the challenge, and then the client would send, after doing this computation here, they would send over a response to the server. And if everything checks, fine, then you are authenticated. The main case here is the challenge portion, where it should be quite unknown. Of course, there will be attacks against that. If you've done attacks on using responder, MITM relay, ito po yun. Don't just run your tools without knowing how they work. What would usually happen is an attacker could sniff a challenge and response, which I'll show you later. They could relay an SMB connection via the network as well, or could sniff or relay and crack them. So responder, MITM6, hashcat, or pcreds, which you could use to extract your NT hash from the NetNTL v2, that tool is what we use. One point of clarification. NTLM v2 cannot be used for pass the hash. Yan na naman, no? Pass the hash would appear in your Windows dashboard, no? Pass the hash cannot be done with NTLM v2. Why? Because this one's a challenge and response, and the challenge and response should be different every authentication. Ang pass the hash, which I'll tell later, is basically authenticating using the NT hash, yung fixed NT hash. I'll talk about that one. So here's how an attacker could abuse that, yung net NTLM v2. Negotiate, the attacker would listen, and basically sa perspective ni server, ang kausap niya ay si client. Just your typical machine in the middle type of attack. Si client, ang perspective na kausap niya ay si attacker. But basically, from here, what happens, no? The attacker could now authenticate as this user on the left side versus the server. But the server does not see that it's not really the real client na kausap niya, but rather the attacker. So that's with NTLM v2. There's so much more attacks about this, but we have to move forward. Now, with password attacks, there's a lot of attacks that are out there. Moving to this portion, I would classify it into two: offline and online. Yung online, yun yung basically brute force, password spray, whatever. Basically, you are connecting to a remote service. Offline attack is an attack that you could do, obviously, offline. Cracking passwords, stealing, or doing Kerberoasting, that's all offline. Now, having said that, there's some differences. With online, you could get detections from it, like from actual authentication failed attempts, right? Offline password attack, no. Well, you could get some logs about when the tickets were requested or other details, but you can't see it being actively attempted. Now, what's the case with passwords? My belief is that whatever minimum requirement we set our users to use as for their password, it's what they will use. Pag sinabi mo minimum 8 character, ang nakikita nila minimum and only 8. That's the reality of how these things work. And if you look at the Windows default domain password complexity, it's 8 characters, uppercase letters, small case, of course, and then special characters. From my belief, summer 2022 works. Winter 2023 works. What is a default period for Windows to change your passwords? Every 3 months. We are lucky in the Philippines, no, we are spared that we don't have seasons. Kasi this will be our problem. This is more of a Western problem with changing the passwords into a season that changes every 4 months. We don't have this issue. But I have experienced this, no? In one of the in the companies I went for on-the-job training, I was wondering before, why was my password fall 2018? Do they watch Game of Thrones? Do they watch anything that has a reference to that? I was wrong. No, I realized after when I went to security, that org is just really a good example. No, so I won't say it. No. So now, how do attackers abuse that? Well, they would use password spraying. Password spraying is an attack where you use one password versus several usernames. What does this defeat? Account lockout. By default, Windows locks you out after 3 failed attempts. So in this case, if I use one password versus all of these accounts, no, if I get one right, what do they say as a hacker? I'm in. Just one. If you have one user out of your 1,000 users who are using summer 2023, 2024, that they could get compromised. Only one failed login attempt for each account. Is this detectable? Yes, obviously. Could imagine, is someone trying to authenticate very small periods of time using the same password over multiple accounts? Yes. The case though is, can you? That's the next question. Okay, so what about unique passwords? Well, there are a lot of ways to implement this, but very common for an attacker is to use or to abuse reused passwords from admins. Now, if you aren't aware, ang general guidance ni Windows or ni Microsoft is to disable the local admin account. Sino dito di naka-disable? Local admin account sa enterprise sila. Mami na kayo, sure ako, hindi naka-disable. So many orgs do not realize that. But Microsoft guidance is local admin should be disabled. And in case there is a need to enable them, you would have to use LAPS, Local Admin Password Solution. Hindi mo na kailangan mag-isip. Brainless, brain-dead thing to do. Configure it, Windows changes your passwords at a set period of time, very complex, unique at every instance. Right? But it's readable, huh? It adds two objects or properties in your AD account. In an AD account, these properties, and it could be read given enough privileges. But is that a blocker? No. I'd rather have that issue than have all of my admin accounts using the same password. How much? Free. So do it, no? If later you go out, call your team, uy, na-research nyo na ba yung labs? Do it, no? So, now, once attackers have gained access to your systems, they would now try to do credential dumping. Obviously, favorite ng mga hackers, get all the credentials. What's the best tool, or rather the flagship tool of doing this? Again, Benjamin Delpy, Mimikatz. He released the tool, as I said before, no, during a con in Russia. And what it does is steal credentials, passwords, tickets, and could even stage instances to reuse those credentials in further attacks. One major thing it could do was it could forge golden tickets. Of course, there are other tools that could do that, but it's one of those things. Another way for an attacker to dump your credentials once they're in, when they gain that administrative privileges, is to use DC sync. DC sync is basically abusing the behavior of domain controllers to replicate information from each other. What's a detection point? This traffic only happens between domain controllers. If you see a workstation and a domain controller having MSDR SR traffic between them, you have a new threat actor inside your environment. No, that is if you're monitoring for this, which is another question. So anyway, so next thing that's going to happen, or if an attacker could do, is to use pass the hash. Ano po yung pass the hash? You know, it's not the hash that you are thinking of. Pass the hash is basically the credentials stored, or rather stolen credentials, and attackers would use this to authenticate remotely. What are the benefits? You don't have to crack it. Because hashes could work, and you could use it to authenticate remotely without knowing the real password. Just need the hash. Now, in some services, it would work in most cases. Can you disable it? Can't. This is how Windows works. So we are stuck in this. Now, but there are preventions to do this, for this, but it's not really direct. What are benefits? You don't really need to crack. No need for lockout because you're basically using the right credential. You're not locking out your account. Now, let's move to Kerberos. Everyone's favorite thing to avoid. That's meme. No one does not simply understand Kerberos. And this is my favorite one from Swift on Security. Sino nakakilala kay Swift on Security? Come on, guys. No, keep up. No? So, what it does, what he tweeted in 2014, one time I tried to explain Kerberos to someone, then we both didn't understand it. No? So, hopefully, this does not apply to me in the coming slides. So, okay. So what is Kerberos? Kerberos is basically the main or the preferred authentication mechanism for Windows. It is ticket-based. Ibig sabihin, it's stateless, sessionless. It does not keep track of what tickets were released. Now, if Kerberos fails, it would fall back to NTLM v2. Now, one of the best advice is to disable NTLM v2. No org will do that. I have not seen that in my lifetime na mag-disable ng NTLM v2 because, number one reason, we don't know what will break. Number two, it's too hard if something breaks. So they won't break it ever. So they won't change it ever. No? And by the way, if you connect to a system via an IP, not the full qualified domain name, you are using NTLM v2. You are not using Kerberos because Kerberos relies on the host name. So how does this work? It has three main elements. Kaya siya Kerberos, Cerberus, three-headed dog. It has three big things. KDC, the client, and the service. The KDC, in a much more technical term, the domain controller. It's basically the function of the DC in terms of Kerberos. Now, there is a client, which is the user requesting access, and then the service that the client is attempting to gain access to. What happens? I'll show it later. This is from Asan's post of how it works, but this is much more simpler. In a nutshell, Let's say I am a user and I logged in and I would want to connect to a file share. Hello, I would like to log in. Can I have a TGT? Ticket granting ticket. Here's my request encrypted with my password. How does this work? Well, workstation or the client would send an ASREC, and that is a piece of information containing the timestamp encrypted with the user's NT hash. So ako, pag nag-log in, Bob, I would send encrypted information, which the key was used, no, a lot of information, was my hash, encrypting the timestamp. Of course, the domain controller knows my password hash. Kasi nga, he's the centralized identity of all of the hashes. The domain controller will be able to decrypt that information because it knows my hash. It checks the timestamp, everything's good, ASREC is done. It will now send me the TGT or the ticket, granting ticket. This scenario relies on the user knowing its password and the domain controller knowing everyone's password. So if another person connects, they encrypt it with their hash, the information they send, the KDC could decrypt it, everything checks. Now, the next thing that's going to happen is after getting that TGT, the user, of course, initially would wanted to access a file share. It will now say, I would like to access CIFS. Now, CIFS is basically the service that is mapped to file sharing. So let's say you want to do SMB or file share. CIFS file share 01, which is a computer account. Can I get a ticket granting service ticket? No. Here's my TGT to prove that it's me. Simple terms. No, I'm not sure if this is how Star City or Enchanted Kingdom works, but let's say you enter a carnival. They give you a band. That's your initial entry to everything pa lang. Once you have that band and you want to go to that ride, let's say yung Ferris wheel, you show them your band. Now, you go to the ticket booth, show them your original band, and they will now give you a ticket for the Ferris wheel. So yung unang-una, the first ticket that you have, your first band that you have, that's basically the TGT. It's what you use to basically say, I'm in here. Now, if you want to use a specific service, you request a ticket granting service ticket. Sorry for the repetition, but ganun talaga siya. No? That's how it happens. So every time you access a service, you connect and request that service ticket. But basically, under the hood, what happens is, I would like to request a service ticket for this service principal name. Yung SPIN or SPN is mapped to a user or computer account. The mapping determines what account's hash will be used to encrypt the service ticket. So if your account has a mapping to this and your password is weak, the information sent is encrypted with a weak password, basically. So it can now be cracked. And that's basically how Kerberos works. If everything checks, here's your ticket, you get that. Now, Kerberoasting was developed by Tim Medin 2014. As I've mentioned, it's basically that type of attack. If you look at here, when the service ticket is sent, it is encrypted with the service account's hash. The main problem, though, is you could request service tickets for any account in a domain. Why will the domain controller allow that? Well, it's too busy. Hindi niya na pwede i-check if you have privileges or not. The entity that checks if you have privileges is the actual target service. That's why it works, is because you could request tickets, the KDC doesn't care. Now, you could get all of your tickets, try to crack it offline, give yourself 2 weeks, get a new credential, proceed with your test. That's why it is effective. Even if the account is dead, even if the service is not working, you could request with that. Now, moving forward, I'm trying to fast track this. With Golden Ticket, how does this work? Well, with a Golden Ticket, you have compromised the TGT, or rather the password hash of the Kerberos TGT account. If you remember, initially, we request TGT with an NTLM pass, and the response to TGT is protected with the KRB TGT hash. I-compromise mo na yung hash na yun. Since you've compromised that, you could forge your own TGT. And inside the TGT, you could fake your privileges. You could say, I am domain admin. So now you could create tickets with any privilege you want, and the KDC will check, tama yan, that's correct. because that's my anti-hash. That's why KRBT, the golden ticket, while it's quite interesting, it's quite boring kasi DA ka na nito eh. For you to get KRBTGT hash, you have to be the main admin, which is basically dead end in some cases. So it's more of a persistence attack rather a privilege escalation. Now, silver ticket is quite similar, but the account or the hash that you have is for the service account. But remember, I said, inside those tickets are your attributes of what you could access. Since you have the key to encrypt that ticket or to forge that ticket, you could basically put or any account username inside, and you could be that one. Let's say you compromise the account, you say, I'm administrator, you forge a ticket, you become admin to that service. That's why it's pretty powerful. So let's move to the last one. Now, ADCS. Anyone here have certificate services in their environments? Not so much. I see some people raise their hands now. This is a much more recent attack, released in 2021 by Will Schroeder. Again, the guy who released Rubius, PowerView. No? I'm pretty sure Microsoft hates him. No? And Lee Christensen, which basically discovered the printer bug. If familiar kayo dun sa coerced authentication with the unconstrained delegation attack, he discovered that one. They released this in 2021, and they said there are 5 credential theft methods, 6 account domain persistent mechanisms, and 8 escalation techniques with ADCS. This is the new thing. I don't think it's new. It's freaking 2021, but most of the orgs don't know this yet. No? So what happens here? No, basically, there are scenarios where you could abuse misconfigured templates. No? There are scenarios as well that could allow you to escalate from being a regular domain user into a domain admin. I will discuss one escalation technique that allows this to happen, only one. When I checked original paper, there was 8. When I checked before, there was so many derivations of other, I cannot talk about all of them. But the main idea is sometimes if you use ESC1, that's how they call it, yung escalation 1, from domain user to DA, it could become that one. There are requirements though for that to happen. Ito. But for me, the last bullet is the main misconfig. Why? The certificate allows requesters to provide any subject alternate name. And that username would be used, no, you would get the privilege after receiving that certificate. And what will the attackers put? Administrator. So me, as CJ, I could request a ticket, put an entry in subject alternate name as admin. When the certificate is signed and given to me that I could use for authentication, I am as admin. Because that's what's in the certificate authentication. That's why it's freaking sick. No? Hopefully you check this when you get back. This is the main issue. You could supply in the request. Basically, you just uncheck this and you're done with ESC1. Most of the time, of course. It's a very general advice. So what can you do? Well, to relaying attacks, most of the relaying attacks are because of DNS fallback. Why is your DNS not working? If you aren't aware, DNS should be the priority, then yung LLMNR, NBNS, NetBIOS, all not used dapat. Why is your DNS falling back? Why is there an issue? Also disable yung WPAD. This is basically when your Windows machine is looking for a proxy configuration, wp.local, disable that. As well as test or disable or enable SMB signing. What can you do with credential stealing attacks? Use domain protected users. Available for Windows Server 2012. End of life na nga yun eh. If you aren't aware. 12 years, the feature is there. In the pentest I've been, only one org I've seen used it. It's freaking free, guys. No? If your domain functional level is 2012 R2, you have it. So check that one out. Check as well protected processes, no? Credential guard, those are good features as well. I'll just highlight no important ones. Implement local admin password solution no, to defeat password attacks. And what I like to mention is yung Microsoft Entra protection. You could set a default block list of passwords and that will be implemented to your domain. The case though is you have to install an agent on each on-prem DC. But come on, it's Microsoft, you have on-prem DC, what's stopping you? Diba? So it's not a third-party account. And lastly, we could all die before everyone use MFA. No? Gumamit kayo ng MFA. So, Kerberoastable accounts, how do you defeat this? Basically, disable the use of RC4. And another feature Windows has, which no one is practically using, I've seen, fine-grade password policy, and even yung group managed service accounts, which I forgot to put. Yung GMSA. What does it do? Active Directory dynamically changes passwords for servers accounts. Wala ka nang gagawin. It's complex, long password, brainless. You don't have to do anything. So, in conclusion, attackers will need initial access. Now, the question though is, can you detect it? That's the main point. No? There's so much attacks going on, but basically, if you look at the end of the day, if you are trying to contemplate of how your 99 years of life has been, is the main point. Can you detect initial access? Now, if you can't, how long can you detect it? Once they gain their access, again, can you detect it? Right? Their actions inside the network, can you detect all of that? Now, these three main points is basically what could help you. You'd want to reduce the way attackers can get in. That's the main point of everything for more protections. Reduce your time to detect, then increase their time to escalate their privileges. Once these two things, okay. That's it. So thank you for listening. Sorry I went over time. Hopefully it was productive for you.
Hello. All right, thank you so much.